In this video, we're going to practice adding and subtracting rational expressions with monomial denominators. We're only going to do monomial denominators this time. This is section 5.10 of Al Grosch's book, Developmental Math 2. So we're going to start right off by reviewing what happens with fractions that don't have variables in them. When we add and subtract a fraction, the one thing you have to remember is they have to have the same denominator. We call that a common denominator. If these two fractions, 5/7 and 2/7, already have the same denominator, so the answer will also have the same denominator. These three denominators are always the same when adding and subtracting fractions. And then the numerators just get subtracted and like terms get combined for an answer of 3/7 here. These are unlike denominators. The denominators are not the same. So we have to give them the same denominator. I usually write these vertically. Your author has written them horizontally here. I'm going to write them vertically. 2/3 plus 1/4. The common denominator is the smallest number that 3 and 4 both go into. We call that the least common multiple, and that is going to be 12. It's the smallest number that 3 and 4 will both divide into. And then to change the numerator, we do a divide here. 3 times what makes 12, or 12 divided by 3 is 4. So the 3 is actually getting multiplied times a 4 to give us the new denominator of 12, and you have to do the same thing on the top for a new numerator. So 2 times 4 is 8 here. 4 times what makes 12, or 12 divided by 4 is 3, and the same thing on the top gives us a new numerator of 3. The denominator is going to be 12. Remember, these three numbers, always the same, 3 denominators. And then we just add the numerators. So we're going to add the 8 plus the 3 coming from here, and that gives us 11 over 12. And that's just a quick review of what happens with regular fractions. Now, once we start putting variables in the fractions, I don't want you to forget what the rules are. The fractions have to have the same denominator to be able to add and subtract them, and these fractions do. So the denominator here is going to be 3, remembering that these 3 numbers are always the same. And then the numerator we're going to add. When we add x and 2, we have x plus 2. And since they are not like terms, they cannot be combined. It does not become 2x. It's x plus 2. When we subtract over here, remember the denominators always have to be the same, and so the denominator of the answer here is going to be 5. These 3 numbers always being the same, and then we subtract the numerators. So we have x minus 3. We're going to add these. The denominators are going to be the same. So this denominator is going to be x. We're going to add the numerators. Now this time, we do have like terms up here once we put the addition in, and so we're going to simplify them. 2 plus 3 is 5, so this becomes 5 over x. So always simplify your numerator if you can, if they're like terms. In the previous examples, they were not like terms. These are not like terms, so they cannot add. These are not like terms, so they cannot subtract. So let's try this one. The denominator is going to be 7x. The numerator is going to be y minus 3. Now, are these like terms? Can I simplify them? No, they are not, so we're done. Okay, here, the denominator is going to be 2x squared. The numerator is going to be x plus 7 plus 3. So that's how I'm going to write it, x plus 7 plus 3. And then I'm going to look and see, are there any like terms? And yes, there are. The 7 and the 3 are like terms, so I can combine those. When I combine the 7 and the 3, I get 10. So this becomes x plus 10 over 2x squared. And remember what we already learned about rational expressions. Don't go canceling things when there's plus and minus signs. On this example, the denominator is going to be 6y. Always remembering these three denominators have to always be the same. Now, the subtraction becomes a little tricky when there's more than one term after it, because if you remember, when you subtract a polynomial, the subtraction sign has to distribute to every term behind it. So we're going to have 5x plus 2 in the numerator, but then we're going to distribute this subtraction sign, and we'll have a negative 3x and a negative 1. So watch for that subtraction sign. It has to get distributed to every term behind it. And now we'll combine like terms here. So the 5x minus the 3x will give us 2x. And the 2 minus the 1 will give us plus 1. And that will be over the 6y. All right, and now we're going to do some not common denominators. So we're going to have to find a common denominator. I just want to review something maybe easy with you, an easy example of finding a common denominator. When we find a common denominator for something like, if we want to add 1/2 and 1/3, they do not have the same denominator. If you know your multiplication facts, you might already know that the common denominator is 6, but why? Why is the common denominator 6? Because it has a factor of 2 and also a factor of 3. So the common denominator has to have the factors that are in the first denominators, the original denominators. So that's how you find a common denominator, by using the factors that are already present in your original denominators. So when we look down here, and we're going to subtract 2/5 minus 3x, we're going to have to find a common denominator. I'm going to call that CD, common denominator. A lot of people call it LCD, lowest common denominator. It has to have a factor of 5 in it, and it also has to have a factor of x. Well, when I put those two factors together, I get 5x, and that will be the common denominator. And then I can change these both to a denominator of 5x. And of course, then my answer is also going to have a denominator of 5x, because remember, these three have to all be the same. So once I determine what the denominator is, now I have to change the numerators. So when you look here, it's the same thing. 5 times what makes x? Makes 5x. 5 times what will make this 5x? Well, 5 times x. So the numerator has to also be multiplied times x, and that will make 2x. X times what makes 5x? X times 5. So the numerator has to also be multiplied times 5, and that will give us 15. And so the numerator here will be 2x minus 15. And there are no like terms, so we're done. Don't make the mistake of trying to cancel these, because this is part of a binomial. There's a subtraction there. These x, this x, and this 15 and 5 won't cancel. So let's add these. The first thing we need to do is find the least common denominator. The least common denominator has to have factors of these original denominators. Well, this is 3 times x. So the least common denominator has to have a 3 and an x in it. It also has to have a 4, but you could use the prime factors here, maybe. This is 2 times 2. Sometimes when you break things down to prime factors, they overlap with the other denominator. There is no overlap here because there was no 2's back here. So we need both of these 2's. When I multiply all those factors together, I get 12x, and that will be the new denominator. Now, sometimes I like to write these vertically when I change the denominators. Some people understand it better this way because this is the way we do traditional fractions. I don't know. It's up to you whether you want to do it vertically or horizontally. 3x times what gives us 12x? 3x times 4. So the numerator has to be multiplied times 4. 4 times what gives us 12x? 4 times 3x. So the numerator has to be multiplied times 3x. And that will give us 3x. So the denominator here is going to be 12x. And the numerator Remember, you are adding. I didn't write the plus sign, but you're adding. So we're going to add the 8 and the 3x. And there are no like terms, so you're done. Now we're going to do the same kind of thing here, except now we're doing subtract. The denominators are x and y. So the least common denominator has to have a factor of x and a factor of y, which makes xy. So I'm going to do it horizontally again. We're going to change these denominators to xy, which means our answer will have a denominator of xy. All right, x times what is xy? X times y. So we need to multiply this numerator also times y, and that will give us 2y squared, y times y. Y times what gives us xy? Y times x. So the new numerator is going to be 5 times x, or 5x. And when I subtract these numerators, I get 2y squared minus 5x. And they do not reduce. All right, we're going to add. I actually think there's more room down here at the bottom to add these. So I'm going down here to the white space. We're going to add y over 2x squared plus 3 over 4xy. All right, so the first thing we need to do is find a common denominator. So looking at this, the factors here are 2 and x squared. That would be x times x. Looking at this, I do have some overlap with factors here because 4 is 2 times 2. That just means that I have to have 2 2's. I already have 1, so I just need to put another one up here. And that covers the 2 2's. I need an x. Well, I already have an x here, so I don't need to put another one, and I need a y. So when I multiply all of that together, I get 4x squared y as a common denominator. So I'm going to do this vertically this time. This new denominator will be 4x squared y. And this is an add. All right, to change these denominators, a lot of people like to think about, okay, what's missing when you go from here to here? What's missing? Or what do I have to multiply times this to get this? Well, I have to multiply times a 2. So I'm going to put that 2 up here because I'm going to multiply times a 2. The x squareds match, so I don't need any x's, but there's a y missing here that pops up over here. So I'm going to put that same y up here. And when I multiply these together, I get 2y squared. So what's missing when I go from here to here? Well, the 4's match. There's an x missing from here to here because this is x squared and this is only 1, so I'm going to need another x. And the y's match, so it will be just the x. So the 3 times the x gives us 3x. And when I add these together, the denominators will be the same. So the denominators will be 4x squared y. The numerator will be 2y squared plus 3x. Okay, we have 4 examples on this page. It looks like on this page, though, they already have the same denominator, so this should go pretty quick here. When we add these, the denominator is the same, because remember, all 3 of these denominators are the same. We just add the numerators, so we're going to add xy plus z. When we subtract these, the denominator is going to be x squared. We're going to subtract the numerators, y minus x. When we add these, the denominator is going to be the same. When we add the numerators, we get x plus 3 plus x plus 4, and we see some common, some like terms. So we're going to combine the like terms. The x plus the x will give us 2x, and the 3 plus the 4 will give us 7. So we have 2x plus 7 over 5y. This is subtract, so the denominator will be the same, 3x squared. This is the case where you have to worry about the subtraction and distributing it because there's more than one term behind it in the numerator. So we'll have 5 minus x minus 2. And combining like terms gives us 3 minus x. Because the 5 and the negative 2 are like terms, that makes a 3. Then we have the negative x over 3x squared. Again, be careful that you don't try to reduce these. These threes cannot reduce because this one is part of a binomial. And the x is the same thing because the x is part of a binomial. All right, on this page, we have to find a common denominator. So we're going to look at the first example. We have 3/4 plus 2 over x. So the common denominator has to have the factors of 4, 2 times 2, and a factor of x. So the common denominator is going to be 4x. So 3/4 plus 2 over x. And we're going to change these to a denominator of 4x. All right, so 4 times what makes 4x? Well, 4 times x. And you have to do the same thing in the numerator. That gives you 3x. X times what makes 4x? X times 4. So you have to do the same thing in the numerator, and that will give you 8, 2 times 4. And now we're ready to add. So the denominator is 4x. The numerator is going to be 3x plus 8. And we're done. This one is subtract, but we still have to have a common denominator. It has to have a factor of x and a factor of y, so it looks like our common denominator is going to be xy. So 5 over x, we're going to change to a denominator of xy, minus 7 over y, also with the denominator of xy. So x times what gives xy? X times y. So 5 times y in the numerator. Y times what gives xy? Y times x. So a numerator of 7x. Our denominator is xy. We're going to subtract our numerators. So 5y minus 7x. On number 7 here, we've got 7 over 6x squared plus 3 over 2xy squared. So a common denominator. First, looking here, the prime factors here are 2, 3, x, x, y. Those all have to be in the common denominator. 2, 3, x, x, y. The prime factors here are 2, x, y, y. Well, we've already got this 2 covered. There's some overlap there. We've already got this x covered. We have only one y, so we've got one of these y's covered, which means we're going to have to put another y to represent that y into our common denominator. When I multiply all that together, I get 6 x squared, y squared, and that will be the common denominator. So 6x squared, y squared. All right, when I look from this fraction down to its new denominator, what's missing between these two denominators to get from here to here? The only thing different is there's an extra y. So I need to multiply that 7 times the extra y, and that will give me 7y. Same thing here. When I look from this old denominator to the new denominator, well, there's missing a 3 because to get from 2 to 6, I have to multiply times 3. So I'm going to have to multiply times 3. There's an extra x down here, so I'm going to have to also multiply times x. But the y's match, y squared and y squared. So I need to multiply times 3x, and that will give me a 9x up here. Then when I add them, the denominator is going to be the same, 6x squared, y squared, and the numerator will be 7y plus 9x. All right, this one is subtract. So let's start with the denominator. This is 5 x's. 1, 2, 3, 4, 5. So we will need 5 x's. This is a 2. So we're going to have to put a 2 in there. And 2 x's, but I've got those covered, and a y. So I'm going to put an extra y on here. So that makes 2x to the 5th y. That will be my common denominator. So 2x to the 5th y. And now I have to change my numerators. All right, to go from this old denominator to the new denominator, what's missing? The 2 and the y. So I need to multiply this times the 2 and the y. And when I multiply that, I get 6y squared. To get from this old denominator to this new denominator, well, the 2's match, but there are 3 more x's. So that would be an x cubed, or 3 extra x's like this, because this one's only x squared and this one's x fifth. The y's match. So I'm going to have 5x cubed here. So when I subtract these, the denominator is going to be 2x to the 5th y, same as these denominators. And then I'll have 6y squared minus 5x cubed.